Hello, everybody. Welcome to IST 110. I'm, of course, Professor S, and this is today's lecture. So, we're going to cover the rest of the material in Zybooks, and we're going to start with simulations and models. So, a model is a simplified representation of an abstraction of a more complex object, system, or phenomenon. A simulation is a model that changes over time. So we need simulations and models to avoid the cost, difficulty, or danger of creating a more complex system. It also helps makes those systems run that much better. Like for instance, remember how we said that systems are a combination of people, technology, and policies and processes. Well, the idea is like if you think about the systems that are required for flying a plane, like a big plane, let's just say that, like a big airline, they might use airplane simulations like this one here to train their pilots so that they could fly better. Now, if you talk to any pilots, they will say that normally it's like once you learn how to do it, it's super easy to take off and to land, right? And to fly normally. Like most of it is mindless, or maybe not mindless. I'm not trying to undermine their thing, their training and their expertise, but the idea is like the real expertise is when those rare moments occur that they need to really hone, like they need to use those certain skills, right? So like if the wind is blowing crazy hard when they're trying to land, maybe like lightning knocks out an engine, or I don't know. Lots of different things can happen that don't normally happen. And so they have to that's when they really have to use their skills to land a plane, usually. I think that's usually the case. It's about landing the plane is the hard, when it gets really hard. So these simulations can not only just introduce people to an effective takeoff and landing, but they can also throw at them weird scenarios too, like those weird gusts of wind or things like losing an engine or things like that, and so that they can be trained and ready for those situations if they occur, and hopefully they don't, but it's just so that you get somebody who's already experienced with that thing without the cost of putting somebody in peril, losing a plane, all those different things. It's a nice tool, right? And that's not the only thing that models are used for. Models can be also used to create simplified predictions of, or sometimes could be a simulation, but the idea is like they can use it's not just about like getting in a machine and flying around. It could be just like a printout, it could be a graph. Those could be models and simulations, and the idea is to see what things are projected to be if they choose a certain option. So that's running a simulation, and those sorts of things. So when in those situations, that's where they're omitting necessary details for the complex system. So it's just honing in on those specific details is what could happen. So it's like, all right, so we worry about like for a if a project is looking at financial considerations, they can ignore outside other things and just hone in on the financial restraints throughout the project. And so anyways, one of the nice things about models and simulations is that oftentimes it allows for rapid and repeated testing and design to develop these more complex systems so that they can take these either extraordinary circumstances, these situations that it's just for whatever the need. The thing is it's like I'm talking and thinking about airplanes and helicopters and that sort of thing. That's what this company does. Fresca, they make simulations for I think it's airplanes and helicopters exclusively. But the idea is like there's other models and simulations that can occur, like forecasting different trends and that sort of thing. And so another thing that these models can do is help visualize a process that's going on. So like say that it's not just about prediction, it's about, or forecasting, it's about understanding where things are right now, understanding maybe if you're thinking about a bunch of franchises, which franchises are doing better, thinking about which franchises do better in different locations. Models and simulations could help with that. Um, and then also, it involves different levels of scale of abstraction depending on the phenomenon being studied. The thing is like these things can be used by anything. Um, and the important thing is to, like, one of the big reasons why we do this is to better understand, better train, better, um, lots of different things. It all depends on the situation. The next thing that we're going to talk about is how organizations, how companies, how different people can get data, right? So, one of the easiest ways that lots of people can get data is through social networks. These are human generated data. So, it could be like the people that they follow, the people that they share, the people that they comment on. That's part of like social networks. Blogs and comments. So this is like the actual information that people put into it. So like for a blog, like the different things that they talk about, the different things that they say actually in the comments. So not just like if they're commenting, but what they say. Then there's the personal input. So like oftentimes in social networks, it asks for more than just what are you thinking? It asks for your name, maybe your birth date, so it can keep track and say happy birthday, or just know how old you are. Those sorts of things are personal information. Pictures, things that you post, and videos, those are things that you do. Another thing that could that people enter in that is kept track of is your internet searches, right? And so it's not just like the ISPs keeping track of you or somebody watching your every move. The search engine people, Google mostly, they keep track of different posts that people do to maybe even come up with more effective results to kind of test to see how well they're doing and that sort of thing. Mobile data, so that includes text messages and things like that. There's user-generated maps and email, other things that people can enter in. Anyways, moving on. Traditional business systems, so they can collect data in different ways. Oftentimes it's financial, but it doesn't have to be. Like, for instance, medical. That's reports that are created to keep track of different people, right? And there's different laws that protect that data, but the idea is like that's still data that's kept on systems. Other data is like I said, financial. So it could be credit card numbers. It could be transaction dates, who was involved, stock prices, different things like that. The IoT also collects data from the different fixed sensors, like weather sensors. That's an easy one. So there's devices that will monitor how much rain has fallen, the temperature, the humidity, like those are different things. Traffic sensors and traffic webcams that keep track of how many people are going through an intersection, which street seems to be the more popular one. Like those are things that they can sense with those things. Also, some things are able to keep track of speed too, and so they are able to keep people tickets. So it's not just how fast individuals are going. Recently, at least in Pennsylvania, with the pandemic, the turnpikes, at least in northeastern Pennsylvania, they don't have people at the toll booths. At least last time I checked. And what they do is, even if you don't have an easy pass, they will still they will take a picture of your license plate and they'll just bill you. Let's see, other things. There's also GPS readings and stuff like that. And then also mobile sensors. So like some cars have different sensors. So whether it's cameras, some have radio frequencies, like especially like the key fobs. I can't think. I'm sorry. and those sorts of things. There's all sorts of different things. All these different devices are collecting data, whether it's for themselves or for others, for weather reasons. And I'm kind of hinting that it's malicious, and a lot of the things that I've talked about is collecting data for malicious reasons, but most often, in order for things to function, they need that to collect that data. Also, there's data from computer systems, databases, and website records. Okay. The last, there's a couple other things I want to talk about. But one of the things that I definitely want to emphasize is a GPS system. So GPS stands for a Global Positioning System, right? This is an example of one of them. I'm not sure. I don't remember if this is one that's still in the air, or if it's no long, or if it's fresh out of the air, or one of the first ones. I don't remember. But it's at least was a GPS, right? And it's something that these satellites fly around in space around the world in a predictable pattern. And so the way that GPS concerns you, the way that we get it on our phones, is that it works with these satellites. And the thing is like the satellites don't find us. It's more like the devices find the satellites. So in a sense, I'm going to hide this. So imagine this is you, and we're going to find that person with these different satellites. So the thing is, it's like a satellite. It transmits data. A satellite, the GPS satellite transmits this data. One of the most important things that it sends out is the time, right? And so a device will pick up the time, and so anything in this area, like on that circle, it will be able to determine how far that device is from that satellite. Okay, so consistently, everything in that circle is going to be the same distance away, because that's how radius works. And the idea is, it's like that signal sent out, it's received, and determines how far that is, because it says, all right, well, the time is actually this, but the satellite sent out the message at this time, because that's the message that it sends out. Like I said, one of the most important things is the time. So it's from that difference, it's able to determine its distance. Then look what happens when we add another satellite in there, right? So we have that other satellite that sends out its time, and it's able to come up with this area, like right where it's in trilateration. It's able to determine that the person is somewhere in this distance, right? It hits at these two different locations, right? So there's two different intersection points. So it says, all right, the distance from these two satellites is here, and it's we know that it's this far away. So there's two possible places. Add in a third satellite, and we're able to determine on a plane where an individual is. So a plane is like a flat surface. And then when there's a fourth satellite, it's able to determine the latitude, like how high somebody is, altitude, sorry. So all four satellites, usually for a device to work, it needs at least four satellites to figure out where it is. Okay, and so it uses those distances to know where it is. So it knows how far those satellites are based upon the time to know where that individual is. And this is called trilateration, using those distances. So even though there's four things, trilateral, it's like kind of like a tri is kind of used for finding a specific place on a flat surface. But like I said, altitude is also something considered, and it also helps with accuracy too. But the thing is, the emphasis that I want to make before I go on to the next slide is that oftentimes people confuse this with triangulation, and triangulation uses the angles to determine the location of something, and that's not what's going on here. It's trilateration because it's using triangles. Well, it's a little bit more than triangles to determine location. It's the distance, not the angle. Okay. All right. Anyways, The fun facts about GPS. So, one is that it's built and maintained by the U.S. Air Force. So, it was originally designed for a military thing, but then I think in the 90s, it was opened up to public and commercial use. Um, the uh, the U.S. Air Force is not the only ones that maintains satellites. There's other countries that have their satellites, like Russia has theirs. I forget off the top of my head all the other ones that exist, but your device uses mostly Americans. So the U.S. satellites are part of Navstar, and the thing is like these have they're once they go up, they don't stay up there forever. They need to be maintained. Well, like I said, they're maintained by the U.S. Air Force. Some of them get replaced over time. They have about a lifespan of 5 to 10 years before they need to be replaced, and so that's also great because as technology gets better, they can be more and more precise. So the GPS satellites that are out there now are helping to create a more accurate system than we had back when they first opened up to the public. The thing is there's lots of things that go into the way that these work. So one of the things is like since they're transmitting information, the atmosphere and their location is something that weighs into their accuracy. So the thing is if you think about like noise, because that's essentially what they're doing. That's radio waves. If you talk into a wall or you talk across the room, it's two different things, right? So like your voice would be muffled through the wall more than it would be across the room. And the point that I'm trying to make is different substances have different speeds of sound, right? And so more importantly, since if we think about assuming that the atmosphere is consistent, depending upon where, here I have an example of a light bulb to help with this. Depending upon where a satellite is, so if we say that you are right here, depending upon where that satellite is, it could potentially go through more atmosphere. The more it's going through a substance, the more that affects the speed of that information getting to the device. So it's something that's considered when thinking about the accuracy of the signal. Other things that affect it is the poles, because there's magnetic poles for the Earth that's affecting the orbit, and sometimes that's predicted, sometimes it needs adjustment, and so like they can tweak the location a little bit and have them move around just a little bit out in space. The other thing that I want to talk about is that with GPS systems is that we usually think about them as being for devices for knowing location, but that's not all they're used for. Like for instance, ATMs use GPS systems because they have a crazy accurate clock. They need that clock, as we talked about before, to determine the distance between the device and the satellite, right? But because they need that such accurate time, the ATMs are able to use that timing to determine what time transactions occur. And so the reason why that's important is because other devices, like if you think about a watch or other clocks, they're not going to be as accurate because they're not based off of such accurate clocks. In order for satellites to work, they're based off of our satellites are based off of our National Atomic Clock, and they use that time to determine what time it is there, and that's the information that they send out to the devices. And it's not just about like one of the things that's interesting too is like they have to adjust their time or anticipate their difference in time, because time is different up where they are than it is on the Earth, because interesting fact, gravity affects time. But, which is crazy, and it's actually observable when we're thinking about these GPSs. So if that observation wasn't made, then it would be a few feet difference at the very best. But anyways, I digress. Talking about the ATMs. So ATMs, since the GPSs are sending out these crazy accurate the times, the ATMs are able to keep track of this times, and that's how they're able to keep track of the accuracy of transactions that occur. And so they say the time that this transaction occurred was at this time. And so they are able to be super consistent depending upon where they are in the US. The more you know. The next thing that we're going to talk about is data analytics. And we kind of have hinted at some of these, especially when we talked about machine learning and things like that. But the idea is like with data analytics, there's 3 different things that are focused on. Descriptive, describing the data, saying, all right, this is going on, this is what we understand. Predictive, this is making predictions, saying, this is what's going to happen given that these things are happening right now. Prescriptive is about making decisions, right? It's about saying, all right, so, and it's not just about like making decisions about the future. It could be about like, well, if this, it's looking like these things are high now, but we only have so many of them, so we need to focus on this other thing right now. Specifically, it's about making decisions. Okay. The last thing that we're going to talk about is the challenges of big data. So as storage becomes cheaper, these are still things that need to be considered. So big data is data that takes up lots and lots of rooms, more so than can fit on our phones, on our computers, and that sort of thing. To analyze that kind of data, it requires special considerations, and we're going to talk about that now. So storage. Large amounts of data, as I said before, require servers and other systems for the data to be stored and accessed. So thinking about these physical locations is something that needs to be considered. Another thing that needs to be considered is the quality of control, making sure the data is accurate and usable. Because just collecting data, there could be mistakes that could be done. It could be thinking about different things that could happen. Maybe people tamper with different sensors or different things, so it's like having to come up with device. And so if you've ever worked with data before, sometimes there's a sense of cleaning up, and so quality control may make sure that there's less cleanup that has to be done. It also could happen from incomplete or poor data that's been identified, filtered, or removed for whatever the reasons, but it's something that needs to be considered. It's part of the accuracy. Another thing is structure. So structure is important for thinking about organization. So just having if you think about like data in a very tangible form, think about books, right? A effective structure is like a library where it's organized the books in different ways. An example of a unorganized thing is just imagine taking all those pages from all those books and putting it in a big pile. That's not going to be very helpful to get any data or any information when you need it, or that organization is super important. So how it is organized on those servers is also something that's important. Privacy, this is also something that needs to be important, especially when it's with sensitive information like financial information, medical records, all those sorts of things, like things that protect people's information. That's things that big data would need to consider. The last thing is scalability, and that's thinking about the hardware and the software required to handle the changes in the data coming in. So it's not just about like having it for this immediate data set. It's also like the data could be getting bigger, or the data could not be even in yet. So it's making sure like maybe you have some data now, but you're going to have more later. And so it's making sure that you have that scalability is something to consider. Okay. Anyways, I think that's good for now. Before I let you go, remember that the quizzes close at 11:59 on Thursday, Eastern Standard Time. So make sure you get your quiz done by then. You have a group project report due by Monday, so don't forget. Anyways, I think that's good for now. I will see you all Monday. Hey everyone, I hope you enjoyed that video. If you did, please press the like button. It lets me know I'm doing something right. If you have any questions about any of the content, please send an email through Canvas to me and the rest of the teaching team, and we'll get back to you as soon as possible. Do not send it through normal email. You will not get as fast response. These are COVID times, so it could take a little bit, but we will get back to you. I promise. Anyways, if you have any suggestions for how I can make these videos better, please leave in the comments below. Don't forget to roundhouse kick the subscribe button and ring the bell to get notified for when I post the next video. Anyway, I think that's good for now. I'll see you all next class.